Hello and welcome to part one of this demonstration of the ErlangCalc software. My name is Peter Loader. I'm the owner of PL Insights and also the author of the ErlangCalc software. If you're not familiar with Erlang and you haven't watched it already, you might want to watch my introduction video, but otherwise let's get straight into the software. First of all, I'll give you a brief tour of the software and show you how to navigate between the different worksheets. Then we're going to create a simple example from scratch that will be based upon a situation where we've got 12 calls arriving per hour on average, each call taking on average 20 minutes to handle. We're going to set a target service level of 80% of calls being answered within 2 minutes of waiting time and a target of a maximum of a 5% abandonment rate. We'll make the assumption that callers on average are willing to wait 5 minutes before they give up if we don't answer the phone. Okay, let's go into the software. So this is the homepage for the ErlangCalc software. If we click anywhere in the main image, then it takes us to the navigator screen. In the top half we've got the buttons to click to go to any of the worksheets that are detailed at the bottom. And in the bottom half of the screen, we've got the license details. So you can see that I'm entitled to use this software until the end of March 2026. The left-hand two columns of the menu options relate to the weekly planner, which we're going to look at in part two. Part one, we're going to focus on the single Erlang calculator. If I click on the button for that, it takes me to the ErlangCalc single sheet. If I wanted to go back to the navigator, then just by clicking on the PL Insights logo in the top left, that will take me back to that navigator sheet. So let's create the model we said we were going to create. Let's start by giving it a description. So we'll call it first attempt. And I normally start my scenario numbers with either 100 or 101, which I'm going to use this time. And we said that there are 12 calls arriving in each hour. So the time period is 60 minutes. The number of calls per time period is 12. The average handling time we said would be 20 minutes. ErlangCalc doesn't really mind how we split between handling time and rack time. If we wanted to get the percentage of contact time, then I guess that could be useful, but it's the total call duration that ErlangCalc is interested in for its calculations. Numbers that appear in pink are actually ones that are formulae, and what you can see we've calculated here is that we would need 4 resources at 100% utilization to deal with that call demand. And that's because if we multiply the average call time of 20 minutes by the volume of call, 20 times 12 is 240 minutes worth of workload. Divide that by the 60 minutes in the time period, and that gives us 4, which is the number of Erlangs, if you like, that we've got, or resources required. We can put in a maximum desired occupancy if we wish. I'm not going to use these parameters for now. So we won't add any team tasks or in-shift losses for breaks or whole shift abstractions to our model. We'll just look at the raw Erlang calculations. We will put a planned resource level in. Let's see what service level we would achieve if we ran with a resource level of 5. Before we can look at the outputs, we need to tell it, ErlangCalc, what the desired performance levels are. So we said that we were going to aim to achieve 80% of calls answered within 2 minutes. We want an abandonment rate not to exceed 5%, and we said that on average our callers would wait 5 minutes before they gave up if we'd not managed to answer the phone in that time. Just at the bottom there's a few parameters to configure the charts that we'll look at in a moment. So that's actually our Erlang model for single time period configured. If we go and look at the outputs, it will tell us over here that we need 7 agents to meet the service standard of 80% within 2 minutes. However, to achieve the abandonment rate of 5%, we'd actually need 8 agents present. Those 8 would only be utilised 50% of the time, which makes sense because we said it would be 4 agents would be 100% utilised. So if we got twice as many, the utilisation is going to be half the amount. And the resource to achieve both clearly is going to be the bigger of those two numbers. So 8 would enable us to achieve both the abandonment rate and the service standard. We didn't enter any of the resource parameters, so we'll ignore that section for now. But down here it does tell us what service level we would achieve at our planned level of 5 resources. So it doesn't look very good. We're only going to achieve just under 50% of our calls answered within 2 minutes, and the abandonment rate would be 43.2%. Callers would wait 11 minutes, and again, not surprisingly, 4 divided by 5 is 0.8, so 80% resource utilisation at that level. If I scroll to the right, I can also look at how the service level and abandonment rates vary according to the number of agents that I've got available. So at 5 agents, which was our planned level, there's our 49.9% and 43.2%. You can see that we first get to 80% when we get to 7 agents on our service level. However, the abandonment rate there is 6.4%, which is why we needed 8 to get down to our below 5% abandonment rate. And you can see how the utilisation changes. What is interesting here is the shape of the orange line, which is the service level, where we can see we get a diminishing return for each agent that's added. So when we went from 5 to 6 agents, we got around about a 27% gain in performance. But when we go from 6 to 7 agents, we're only getting 13%, then we only get a 6% gain, then a 2.6% gain, etc. So one of the lessons we get from this is that having very high percentage numbers in our service level can be very costly in terms of the resources required to achieve those gains. Finally, on this screen, I can copy the results from this scenario into the scenario store. All I need to do is highlight all the numbers in the orange column, press Control C to copy that data, go to the single scenarios and paste it into the first available column. So that's pasted the stored scenario into our table of stored scenarios, and we can now start to examine the scenario in the same chart that we saw before, or by comparing it once we've created a second scenario in the scenario comparison chart. So let's go and create another scenario to look at. So we go back to the Erlang Calculator, and what we're going to do is see what the effect is of doubling the amount of demand in the time period. So we'll create a new scenario. We'll call it double demand. We'll make it scenario 102, and we need to increase the demand, the calls per period, from 12 to 24. You can see now that the resource at the 100% utilisation has gone up to 8, which is what we'd expect, and therefore we're going to need to increase our planned resource level. Let's put in 10 there and see what impact that has. So if we come over to the outputs, we can actually see, if you remember, the amount of resource we needed to achieve our target service level was 7 before, but although we've doubled the demand, the amount of resource that we require has only gone up to 11, and they'll now be 72% busy. That's quite significant because it suggests that as we increase demand, we may not need to increase the resource by as much as we might have thought. This is what's called an economy of scale, but just to look at that more closely, let's copy this scenario and paste it into the scenario store and compare the two lots of numbers side by side. So again, let's copy the numbers in the yellow. That includes all the numbers for the chart plus the input parameters that we set up. Let's paste it in there. There we go. So you can see that whereas we needed 7 to get a service level, it's now gone to 11. To achieve the abandonment rate, 8 went up to 13, and we're getting a higher utilisation. That's quite significant. It's what's known as an economy of scale. It means that if, for example, we had 2 different teams handling the same work, if we blended them into one, then rather than needing 2 lots of 8, we'd now only need 13 people to deal with the same amount of demand. If we look at the comparison of scenarios 101 and 102 over here, and look at, for example, the utilizations and the performances, we can see that 7, which is what we needed here, we only got 57% utilization, the 72% utilization over here with 11. The final thing I was going to show you on the single Erlang calculator was how we can use this to look at the impacts of in-shift losses and abstractions. So it could be, for example, that we don't want our people to be more than maybe 85% utilised. In this case, it's not going to make any difference because to achieve the service standard, they're only 73% busy anyway. But if I set that at 70%, you'll see, in fact, we need to set it lower than 61%, so let's set it to 60%. You'll see now that when we look at this table, we now need to have 14 rather than 13 resources to achieve our service level because we're not allowed to go above 60% utilisation. That's probably a bit unrealistic, so we'll set that back to 85%. It could be that we have other jobs that these people need to do while they're answering calls. We maybe need a couple of people's worth for that. It could be that we allow them to have 6 minutes off of a rest break in every hour, so we could have a 10% in-shift losses figure. And maybe when we've allowed for leave and sickness, that we know that 25% of the time people aren't actually going to be available to work. And these numbers are all updated over here. You'll see it provides the number calculated as a decimal and then rounds it up to the nearest whole number in each case. So actually, to achieve our 13 people needed to answer the calls with an abandonment rate of less than 5%, we would actually need to roster 23 people by the time we've allowed for the team tasks, the in-shift losses and the whole shift abstractions. That's it for this part of the demonstration. We'll come back and have a look at how these principles are applied to a weekly plan in part 2. So just to recap, the first scenario required 7 agents to achieve the service level, but 8 if we wanted to achieve the abandonment rate of 5%, utilised at 57.1 and 50% respectively. If we doubled demand, we might have expected the number of agents to go up to 14 and 16, but actually it only went to 11 for the service level and 13 for the abandonment rate, with utilisation rising to 72.7 and 61.5% respectively. This is an example of an economy of scale that might be gained, for example, by combining 2 teams that are geographically dispersed or multi-skilling across different call types rather than having dedicated pools of resource. So, thank you for watching so far. In part 2, we'll take a tour of the inputs from the weekly planner. That's going to include running some scenarios, including testing an alternative shift pattern to see how it compares with a flat resource profile. Not only that, you can find out how to buy ErlangCalc. See you soon.